This is Mr. Hardesty. In our next problem, we'll find the numbers of positive and negative zeros. State the possible number of positive real zeros, negative real zeros, and imaginary zeros of h of x equals negative 3x to the sixth plus 4x to the fourth plus 2x squared minus 6. We recognize first that we have a sixth degree polynomial, which means there will be 6 zeros. They may be real or imaginary or a combination of both, but there will be 6. Then we'll use Descartes' rule of signs to determine the number and type in those possibilities by looking at sign change. First, the original, that'll determine our positive real zeros. So let's look at the sign changes for h of x. We'll start with the first term to the second term, and there is a sign change from negative to positive. So there's 1. From this term to 2x squared, there is no sign change. And finally, from 2x squared to negative 6, there is a sign change. So 1 plus 0 plus 1 is 2. According to Descartes' rule, we have either 2 or 0 positive real zeros. Now we'll do the same thing for the negative real zeros by evaluating h of negative x. And when we do that, we will represent in our function negative x each time as we raise it to the 6th power. And here we raise it to the 4th power. Now to the 2nd power, and the same constant. When we simplify, raising those to an even power, we see the exact polynomial that we had to begin with. Raising those to an even power will make them positive. So when we evaluate sign change, we'll see similar patterns. That is, from the first to the second term, there is a sign change. Between these two, not a sign change. And from 2x squared to negative 6, yes, a sign change. So similar math, where once again we'll see 2 or 0. Those are our options for the negative real zeros. Now we'll use our table down at the bottom to represent all the possible combinations of real and imaginary zeros. We know the total number in every combination will be 6. Right? We said off the top that 6 zeros for a 6th degree polynomial. For our number of positive real zeros, remember we had 2 or 0, so we could say there are 2 real zeros that are positive. That could go with 2 real zeros that are negative. If we have 2 there and 2 there, we know that's 4. Well, then we would need another 2 to get to 6, meaning 2 of them might be imaginary. So there's one possible combination. We could have 2 real positive zeros and 0 that are negative. Thinking the same way, we'll need 4 imaginary to get our total of 6. Now, we also know that we could have 0 positive real zeros. We could pair that with 2 that are negative. Once again, that'll leave 4. Similar math to what we had in the previous example. 2 plus 0 plus 4 is 6. And finally, we could have combinations where there are 0 positive real zeros, 0 negative real zeros, and of course we know we would have to show that all 6 are imaginary to get our total. So in our chart, we have shown all possible combinations of real and imaginary zeros using Descartes' rule of signs.